order matters. Combinations, order doesn't matter. So arranging letters for word, order matters. Every time you hear the word arrangements, order matters. When you give people jobs or titles like president, vice president, when you send them to different places, right? When they win award, like, so say you have 3 prizes that people can win, and the 3 prizes are totally different. Then does the order in which you pick those 3 prizes matter? Yes. But what if the 3 prizes are the same? Then it would be a combination, right? Itineraries. Itineraries are like tells you I'm going from this place to this place to this place to this place, right? That's your itinerary. Like we're flying to Toronto, then we're going to go to London Heathrow Airport, and then da-da-da. That would be itinerary. People sitting together or lining up for a picture. So the moment you put someone in for a picture, or you line a book, or you put like a book on a shelf, order matters. PIN numbers, license plates, order of winning, first, second, third, different prizes, stuff like that. Combinations is what we started yesterday. So groups of people where titles are not given. So best 3 go on to another level, or 3 people get chosen to go on to the same trip, right? Or you do a 3-person subcommittee. Card hands are also combinations. Because the moment you get cards, what do? The moment you dealt some cards, what's the first thing you probably do? Move them around to whatever the heck you think. So like if it was hearts, you put all the different different suits together, right? If it's like Uno, you put the colors together. So the first thing you do when you get cards is you move them around. So do you have to play them in the order that it was handed to you? No. So that's why it's a combination. Handshakes, order doesn't matter. It's not like the first person to get to the hand is better than the other one. Like 2 hands meet, you shake. Okay, it's a combination. Pizza toppings, although any good cook knows otherwise. Pizza toppings and stuff like that, making chili, order doesn't matter. You throw it all in one pot and poof, you have chili. Now, obviously, you're not going to do that, but you can. Joining dots to form figures. So if you have like a circle and you have dots on the outside of the circle and you're trying to draw triangles from it, the order in which you make the lines, meet the 3 lines together to make a triangle, still makes the same triangle, no matter what order you pick, right? You do this line, this, or then this, same triangle. So it'll be a combination, and diagonals would be combinations. Also, what I want to add to this list is when you choose from the same item. So example, when you take principles from principles. When you choose boys from boys. When you choose forwards from forwards, like in hockey, or in other sports that have to. So the moment you're choosing, I know I've seen it as clubs before, so like it might be irons from irons in golfing, okay? The moment you choose it from the same group of itself, order doesn't matter because you're choosing principles from principles. Now, if I was going on a trip and I was choosing one principal, one teacher, one student from a group, and you could all be teachers, students, or I don't know, administrators, then it would be a permutation. But if you're picking people to go on a trip, and you're picking principals from principals, students from students, teachers from teachers, it's a combination, right? Some people say, well, they're different jobs. Yes, but I'm picking principals from principals, teachers from teachers, students from students. If I had a 10-person subcommittee, and I was picking a principal, or a president, a treasurer, and a secretary, right? Then it would be a permutation. I would do 10p3. We agree? But if I said I'm picking the treasurer from all the treasurers, from the 10 treasurers, and the secretary from all the 10 secretaries in our school division, let's say, and the treasurer from all the treasurers, whatever it may be, then it would be a combination. Because you take the number of principals and choose one, the number of secretaries and choose one, the number of treasurers and choose one. Okay? So if you're choosing them from the group that's exactly the same, it's a C. Principals from principals, teachers from teachers, irons from irons, forwards from forwards, New Democrats from New Democrats. Okay? So, go back to our combinations where we left off. We were here. Example 3. So we have the athletic council describes or decides to form a subcommittee. Okay, cool. We have an athletic council. We're forming a subcommittee of 7 council members. So in the end, I need 7 people. Then I have a committee. We agree? Now we figure out what the big committee is that we're choosing from, but ultimately in the end I'm going to have to choose 7 people. We know that. To look at how funds raised should be spent on sports activities in schools. Here it says there are 15, so that's our total, 15 athletic council members. We need 7. If that was it, if that was all that was asked, we would go 15C7. We agree? All right. Cool, we're back. So oh, I have to recover from my sneeze. All right, so it would be 15C7, yes? But there's more to this story, so we keep reading. So it says, of the 15, there are 9 females, or 9 males and 6 females. The subcommittee must consist of exactly 3 females. Cool, I need exactly 3 females. But how many people do I need on the subcommittee? 7. We agree? So if I need exactly 3 females, I indirectly also need exactly what? 4 males, right? So determine the number of ways. So we have females, we need 3. And males, we need 4, because we need 7. And if we add that up, we get that, right? 3 plus 4 equals 7. Is that not a true statement? But now we have to choose them. How can we guarantee getting females? Choosing from the females, yeah, the 6 females. So we're going to do females from females. Oh, the moment we do females from females, we know it's a combination, right? Principals from principals, students from students, forwards from forwards, defense from defense, girls from girls, boys from boys. It's a C every single time. So it's also a C because this council members don't have any jobs, right? They're just on the student council and they're not, so it's a C. But we're going to go 6C3. Now, we're not going to use a plus sign in between here. We use a plus sign to get the 7. I'm going to take those out to confuse people. But do I need the females and the males to make the 7, or the females or the males to make the 7? And the moment I use the word and, what do I do? What operation? Multiply. Because and add do not go together, right? And, multiply, or add. Correct? So we need 3 females and 4 males, so we're going to multiply. And you need to know that, because guess what they're going to give you for answers? This is the right answer, 6C3, 9C3, or 9C, that's not the right answer. 6C3, 9C4, sorry. What else will they give you? 6C3 plus 9C4. What else will they give you? 6P3 times 9P4, and the other one they'll give you is 6P3 plus 9P4. So any oopsie will be there. So you need to know your stuff, okay? So if you're like, I kind of know my stuff, that's a scary place to be, because all the kind of other answers will be there for you to pick, okay? You need to know what you need to know. So you need to know that I need 3 and 4, so I'm going to multiply. I know that they don't have jobs, so it's a C, okay? So type that into your calculator. Everyone go practicing. Just because I can type it in doesn't mean you can. You should be getting 2,520 different committees. Remember how big our numbers were with P's? Because order mattered, P's have big numbers, correct? Combinations often have smaller numbers because the order doesn't matter. It doesn't take into account any of the different arrangements. Like I'm not arranging these 3 females now and moving them around each other, right? Now, how could I change this question? Well, this is where the perm-com mix questions come in, and there will be one on your test for sure. This is a sheer com question, right? I'm making a 7-person subcommittee, that's it. I need exactly 3 females, boom, boom. How could I make this a perm-com mix? Okay, I have the athletic council decides to form a subcommittee of 7 council members to look at how much funds can be raised, should be spent on sports activities in the school There are a total of 15 athletic council members, 9 males, 6 females. The subcommittee must consist of exactly 3 females. And then I take a picture of everyone. That's how you make it a perm com. You still have to do the combination just like this to get to choose those people, right? I do the C's to get the 7 people. But then I want to take a picture of all of them. So now I have to arrange them as well. So a little caveat, if I then wanted to take a picture, I now have to arrange these people, correct? So I would still have the 6C3 to choose 3 females. I would still have the 9C4 to choose the 4 males. Because if I'm choosing females from females and males from males, it is a C. That will never be a P, just so you know. How do we get the P part? Well, we go, now I want to arrange them. So 7 of them can be here, 6, 5, 4, 3, 2, 1. This is literally me standing them side by side by side. So I could put 7 factorial. I could give that as my answer. I could give my answer as 6C3 times 9C4 times 7 factorial, correct? Or I could go 6C3 times 9C4 times 7P what? 7 is the total number we're starting with, P, and then the back part is how many blanks. How many blanks are there? 7. I have 7 and I'm picking 7. So those would be the answers if I chose them and then I put them in a picture. Took a picture of them. There will always be a perm-com mix on your test. All of those. We'll do a few other ones after too. Okay, cards. You can always ask me, are there 13 of this or is there whatever this for the test? Because on your diploma, they'll either give you the array of what the cards all have in them, or they totally make a different suit that no one's ever seen before, like a totally different set of cards. So they'll say there's 4 suits, one's pink, green, blue, and orange, and they're numbered 1 to 10, so that everyone has a fair shot whether you've played cards or not. Okay? But we're going to use the normal card deck for these. So every standard deck of cards is 52 cards. There are 4 suits. There's spades, clubs, diamonds, and hearts. So if there's 4 suits and there's an even amount of them, 52 divided by 4, there's 13 in each suit, right? 2 suits are black, the spades and the clubs. 2 suits are red, the diamonds and the hearts. And face cards are considered to be jack, queens, and kings, which means there's 12 of them, because there's 3 per suit. So 3 times 12, 3 times 4 is 12. And then here it says, poker is a card game played from a deck of 52 cards. So now, I want how many 5-card poker hands are possible. Is it asking for anything specific? So I'm going to choose cards from cards, right? So it's a C. How many cards are there? 52. So 52 C5. So there are 2,598,960 different poker hands that you could get out of a deck of 52. Now, like if you were doing like 2 2s and 3 3s, right? You can get a few different types of that, but they would still count as the same thing, but they would look different, so therefore they're called a different card. So here it says, okay, that's how many maximum there are. Just like when we did the word kitchen, we found the maximum amount was 7 factorial, right? The maximum number of card hands we could get is 2,598,960. But now I want to know, okay, of those 2,598,960 hands, how many of them would be all diamonds? So what if I want all diamonds, what do I have to choose from? All the diamonds, that's it, right? So how many diamonds are in a deck? 13. Every suit has 13 cards, right? So I would just go 13, see how many? 5, because it's a 5-card hand, right? So of those 2 million, like a whole bunch of cards, only 1,287 of those hands would be all diamonds. So that could be like a 1, 2, 3, 4, 5, a 1, 3, 4, 5, 6. You know what I mean? So it's all the diamonds. So it should be a smaller amount, right? Now, I want, in how many of the hands in A will there be 4 black cards and 1 red card? How many cards is that? It's 5, right? There's going to be 26 to choose from, but that is 5 cards, right? So is that good? We have 5 cards. We need 5 cards. Yes. That's the first thing you always need to check for. Are they asking me to find 5 cards? Because I need to find 5 cards, right? And then we're right that there black cards. There's 26 of them. So I'm going to do 26. Choose 4. And means I do what? Multiply. And then red, once again, there's 26. Choose 1. Like I said, everyone should be typing them in. If you don't have a calculator, I have a calculator graveyard up here. You can grab them. There's nothing worse than when the test comes and someone asks me where the P and C button is. You're a dead ringer away from you didn't do your homework and you didn't use your calculator. So now we have a much bigger answer. Does that make sense? Yeah, because we're not limiting it even to a suit, right? We're limiting it to reds and blacks. Now the next one, 3 kings and 2 queens. You try it out. How many kings are there? 1 in each suit, so there are 4. Yeah. Choose 3. And queens? 4, choose 2. And what do we get? Okay, here's where it starts getting a little harder for people. Because it just says 3 kings. And people will say, oh, it's 4C3 and give me the answer. Except I need a how many card hand? I need 5. Okay, this is where you need to put your thinking caps on. I need exactly 3 kings. So am I allowed any more kings? So can I choose from the kings more than that? No. So it's 4C3, that's right. So I need 3 kings and how many other cards? 2. So I need 3 kings and 2 not kings. So anything but a king. We agree? So if there are 4 kings in the deck, how many are not kings? 48. Now some people will say, well, I didn't use the other king up, so I can put 49. No, you can't, because then you could possibly get 4 kings, and I need 3 kings, right? So I need to choose from the kings first, and then the next one needs to be anything but that. So what was this first number? It's 52 minus this first number. So it's 48 cards left that aren't kings, and I'm going to choose 2. You try the 4 aces. Keeping in mind I need 4 aces and what? 1 not ace. Yeah, anything else. Let's try it out. So it's going to be 4 aces and 1 not ace. So it'd be 4C4 for the aces. And how many not aces? 48, yeah. What do you get? 48? Because 4, choose 4 items. It's like walking off with all the toys, so that's one way. 48, choose 1 at a time is 48 ways. You choose 1 at a time, right? 48. Now this one says 5 cards in the same suit. Does it tell us what suit? No. So we're going to have 5 diamonds, or 5 clubs, or 5 spades, or 5 hearts. How many diamonds are there? 13, and we're going to choose 5. Or means we do what? Add clubs. 13, choose 5. Spades. 13, choose 5. Hearts. 13, choose 5. What could we do instead of adding all of these? For this one, we're just going to look at number 4 for now. Number 4 wants us to solve it algebraically. So NC2 equals 10. So I know that n has to be greater than or equal to what in this case? What does n have to be greater than? Nope, in this case. Specifically this case. Your n has to be greater than or equal to your r, correct? You can't have like one item and choose 2. You can't have like one spade and choose 2 spades. That makes no sense, right? Could I have 2 spades and choose 2 spades? Sure. Could I have more than 2 and choose 2? Yes. So I know for a fact that my n in this case is going to have to be greater than or equal to 2. So I could go 2c2, 3c2, 4c2, 5c2 till I get 10, right? I could do that. However, this says algebraically. So if you do that, you're going to get no marks on the diploma. Because that's not algebraically, that's guess and check. Okay? Algebraically means I have a formula. I need to put it into that formula. Remember the formula is this. NCR equals n factorial over n minus r factorial r factorial. So for us, n is n, r is 2, and then we fill that in and set it equal to 10, right? So I'm going to fill it into this part here and set it equal to 10 because it equals 10. So I'm going to get n factorial over n minus 2 factorial equals 10. So you can solve the p's exactly the same. You just won't have this extra number on the bottom, right? You'll have everything else but the 2 factorial. We agree? What is 2 factorial? 2. So we have n factorial over n minus 2 factorial times 2 technically equals 10. So with the p, we would just go ahead and solve it like we did before, correct? But with this one, I want to move that 2 first. The 2 is being divided. How can I move it? Multiply. No way. What am I doing? I want this. Okay. So which one's bigger? The top always with this formula, right? The top is always bigger because it gets rid of the bottom. And then we can just FOIL and then move over and factor. We've done this before. So we're going to get n minus 1, n minus 2 factorial. It matches. So we stop. Then what's our next step always? Distribute. So n squared minus n equals 20. And what do I have to do whenever I put squared? So which one side set it equal to? 0 every time. And if you forget, remember I told you, it says right up here. But multiplies can be negative 20 and adds can be negative 1? Yeah, sorry.
I'm just a little confused. What happened to the factorial next to the 2?
2 factorial is 2.
That's a good point.
So we can change whatever that factorial is because it doesn't have a variable
Yeah.
to 2. Trust me, everyone is thinking the same thing. You just said it, so you're fine.
Okay, sounds good.
If we, yep. Yes. What happens here? Great, and this explains it again. We're back up to, this is our equation. So this explains it again. Okay, I take the 5. I go 5C2 into my calculator, I get 10. It proves that I'm right, correct? Can I go -4 items, choose 2? That's even worse than no items, choose 2. That's like you like lost some items and then you tried to choose some from it, right? So that doesn't make any sense. So this one works. This one, we circle it, we put a line through it, and we put extraneous. And you might be like, well, that's overkill, Mrs. Lepp. I'm not doing that. You have to. It's how you get the full marks. We all make choices. If you choose not to do that, you will choose to not get full marks. Okay? Because you're kicking it out. You're saying, here was a solution. It doesn't work. It's extraneous. Like it's got a sentence with it. Here's my solution. Ooh, it's beautiful. No, it's not. Extraneous.
You can just do like the XD, right?
No. That could be exit without an I. That could be extraterrestrial, which we don't want. That could be extraneous, which might be a person's name. It could be extraordinary, which is what this conversation is right now. So we can't use EXT. The only short form in math we can use is when we get to trig, there's an LS and an RS for left side and right side, because in math textbooks, it's stated that LS stands for like left side and RS stands for right side. That's the only short form. So if you are short forming on a test, you are causing yourself problems. So never. If there's a time to save pencil, it's not on your test. Like use your pencil right up. I will provide you with another pencil. Okay.
Math, like the diploma is not multiple choice though.
Nope. The diploma is 24 multiple choice, 8 numeric response, 3 written. That paper I gave you goes through exactly what's on it, remember? So you'll have your 24 multiple choice, 8 numeric, 3 written, and the 3 written are out of, there's 2 parts to each written. One will be out of 2 marks, and one will be out of 3 marks. So each written's out of 5. Multiple choice numeric make up 75% of the test, and the numeric, or the written response makes up 25%. So they literally take this part times by 0.75, take the written times by 0.25, and add them. And on your transcript, you'll see the breakdown between the, they'll show you the breakdown of both, and then the total. All right, we're over here. These are the extensions. These are the bad boys that I star, because these are the ones that are done a little bit crappier. Crappier is a word, and I just said it twice on the podcast, but that's all I got. It's crappier. Because you have to do these are often in the written response, right? If you were in a multiple choice or a numeric response, you wouldn't have to get away without algebraically, because I wouldn't be able to see it, right? Therefore, they're found in the written. Now, the ones we've done to this point is, I want 3 boys and 4 girls, and I make you choose boys from boys, girls from girls, right? I have a subcommittee. I do this. I want you to tell me how many hands there will be with 3 kings and 2 queens, but I give you the total number that you're choosing from, yes? These ones, you have to, I'll give you the answer, and you have to find how many people were there, maybe, in the meeting, something like that. So you're looking for n in these cases. So how did we just solve for n? Well, we just solved for it. We used the formula on a formula sheet, right? So let's look at these ones. They're a giveaway because they'll give you the total. They'll say the total number of handshakes is this. So they give you the answer. Total means answer, okay? So here we have, in a meeting, everyone shakes hands with everybody else. Hello. Hello. How are you doing? Great job. Hi. Like, you know, you're shaking hands with everyone else. Okay? Cool. How many people shake hands at once? 2 people. True statement. Yes? You're all like, of course, it's 2. 3 is really awkward. I know, but then I get really weird numbers for the R value on NCR. Okay? If 2 people are shaking hands at once, I'm choosing 2 people to shake hands at once. Correct? So that means, and also does shaking hands matter? Order? Like, I got to you fast. I got to you, you're slow. It's a light handshake. Does it matter? No. 2 come together, shake a hand, counts as a handshake. We agree? So, the order in which you choose the 2 people doesn't matter because they come together, shake hands. Yes? So I know it's a combination. And this number 2 here represents how many people shake hands at one time. So when you put a 3, you're thinking that 3 people are shaking hands together at once. Or you put a 10, that's a real awkward handshake. Like it's like, break. You know, football or something like that. 2. It's 2. You all tell me 2, and then you'll give me not 2 there. And then I'm just like, what is going on? Okay, cool. We got to that part. Everyone shakes hands with everyone else. Cool. There are 66 handshakes in total. What did they give me? Give me the answer, 66. And it says, how many people were in the meeting? What am I asking you to find? N. Now, if you go 2C2, 3C2, 4C2, 5C2, 6C2, 7C2 till you get 66, how much marks are you getting on the diploma and on my test? Well, if you wrote out this equation, you're probably getting 0.5 out of 3. That's not good. Like, it's bad. Okay? So, when it says algebraically, you have to do algebra, which means mathematics, not 2C2, 3C2, 4C2 in your calculator. Okay? Could you do the 2C2, 3C2, 4C2 to make you feel better when you're done and check it to make sure you got it right? Yes. You could do that ahead of time, make yourself prepared. You could put your answer in at the end to make sure you're right, correct? You should do that. You should be checking it. So we're going to go to our formula. So this is our N, this is our R, N is N, R is R, or R is 2, and then that's our total. So we get N factorial over N minus 2 factorial, 2 factorial, equals 66. To multiply by our 2. And we get N factorial over N minus 2 factorial equals 132. And then you get N minus 1, N minus 2 factorial. What multiplies to give us negative 132 and adds to give us negative 1? N minus 12, N plus 11, N minus 12 equals 0, N equals 12, N plus 11 equals 0, N equals negative 11. Now, how I told you, you need to know your 10 and 11 math. I told you that you do. This filling it into this formula and getting to N squared, to getting to this N minus 1 equals 132, that is grade 12. This is grade 11. Factoring is grade 10. Answering is grade 11. So half of this is not this year's math. Right? So we need to know our previous math. And if we don't, we need to get past denial. So we put 12C2 into our calculator. It gives us 66. We're happy. We feel like we have just won the lottery. We know we got the question right. And then we walk off. No. We take this negative 11, we circle it, we put a line through it, and we say extraneous. So this one here, number 2, says, there exists a circle. Cool. It was relatively circly. Perfect. With 6 closed dots on the circumference. Does it say where the 6 closed dots are? No, but I'm a rebel, so I'm just going to pick my own spots. I used to do them evenly because it bothered me when they weren't, but now I'm a rebel and I can put them anywhere. They don't have to be even, right? Cool. How many triangles can be formed using these 6 dots? How do we do the question? How many do we have to choose from? 6. Does the order in which I pick these dots matter? For example, if I go like this, or I go like this, or I go like this, do I get a different triangle? So is it permutation or combination? Combination. Yeah. Order doesn't matter. Now, how many am I choosing to make triangles? 3. 6 dots, choosing how many dots? You think of it that way. 6 dots, choosing 3 dots at a time. So what do we get? 20? So we can make 20 different triangles. Now, could I have given you the total number of triangles and asked for how many dots? I absolutely could, right? Total just what it equals to. Triangles means any 3 dots. N would be how many dots? Okay, extension number 3. Every team in a league plays every other team 3 times. I'm going to say in a hockey league. So, I use C. I say the order doesn't matter. But how many am I going to choose from? Like, how many am I choosing to play? Nope. How many am I choosing to play? How many handshakes did I need to make a handshake? How many hands? I need 2 hands to make a handshake, correct? How many teams do you need to make a game? 2. So you're choosing 2 at a time. Same thing as the handshakes. So this is going to be a 2. Because it's how many you need to form a game. How many hands did you need to form a handshake, right? Now, for games, it'll always be 2 unless they come up with some convoluted, like, soccer game where 3 teams play each other at once or something like that. Then you would choose 3, right? It's how many you need to form a team. Okay. They play each other 3 times. How do I deal with that? I just go multiply this by 3. If they played each other 4 times, I'd multiply by 4. If they played each other 10 times, I'd multiply by 10. That's it. It's the only difference. Now it says, how many teams are in the league? If they play 3 times. How many teams are in the league? So N. If they play a total of 198 games. So what's the first thing I'm going to do so that it looks a lot like the previous time I did this? What should I do first, James? Divide 3. Get that 3 out of there. What do we get? Go. Right up. Algebraically. If you haven't noticed, it ended up being the exact same as the handshake question. I did that intentionally. Now, if we just say n equals 12, is that enough if this is a written response? You should always have a statement. Always in a written response, state what you know. Like sometimes it'll ask for the exponent on something. Well, you have to write, the exponent is blah, right? Because people will just give us an answer like 3x squared y. And I'm like, cool, what's the exponent? And the reason why we have to see, oh, the exponent on the x is 2 or whatever, is because when people start circling, sometimes they'll circle the 3. And they're like, well, that's not the exponent. So you have to actually have a statement whenever it's written response. So for this one, I would say there are 12 teams in the league. We have at most and least to still go over, but I'm actually going to hand you out your daily quiz now because it has mixed terms and commas. You're going to try it out.